I'm going to show you a little bit about residential foundations. Make sure you add these notes to your Google Doc. Let's take a look at Niccolo Machiavelli, who said, "He who has not first laid his foundations may be able with great ability to lay them afterwards, but they will be laid with trouble to the architect and danger to the building." And he said that so long ago that he's probably dead. So let's take a look at the purpose, consideration, and types of foundations. First of all, purpose, you should note these three things. It provides a level and stable surface to safely support a building. It transfers the building loads to the soil down below. And then it anchors the building from wind, flood, and seismic load. Don't write this down yet. Design considerations. Things to consider: loads from the structure, allowable soil-bearing pressure, frost depth, flood elevation, drainage, and cost. So we're going to talk about each one of these in detail. First, loads from the structure. The foundation must resist these three things, important things. One is the dead load. The dead load is the weight of the building itself, all the materials in it. It has to be able to support the weight of the roof and the weight of the shingles and the weight of the doors and the windows. That's dead load. Live load is things that you put in it, like furniture, occupants, because furniture is something that you might move around from place to place. So the floor has to be able to support the giant grand piano that you put in the middle of the floor without collapsing. And lateral loads like wind, seismic activity, and floods. Allowable soil-bearing pressure. This indicates the maximum pressure that a soil may be designed to support. We are going to actually calculate soil-bearing pressure later on in the spring. We're going to do a soil survey outside, and then we're going to figure out what different types of soil will support different sizes of foundations. So different types of soils have different allowable soil-bearing pressures. Sands may not be as good as things like gravel and rock. Soil information, you can find information from local building departments. We're going to use this site, this web soil survey, later on in the semester. Building codes. There's also a soil testing or analysis. So we're going to use this site here, and we're going to do an analysis. So nothing you need to write down here, but just so that you know, we are actually going to do an inspection and soil testing with a soil boring. That's just drilling a hole down and taking out the sample that you found, and then test that out. Frost depth is a really important piece for foundations. Freezing of soil can cause heaving of foundations. Silt and clay soils with a high water table are highly susceptible to frost if you have lots of clay. So your defense against this is to build below the lowest frost depth. When it gets super cold outside, then the ground freezes, freeze, but it only goes a certain depth. And then in the spring and summer, it thaw. So if the frost only goes this deep, that far down, and you put your foundation below that, then it will never be frozen. So that won't ever cause anything to heave. If you've ever put a pop bottle into a freezer or a can of pop or something into the freezer, you know that water expands when it freezes, and that can cause things to move. If soil gets water in it and it freezes, it expands, and that causes your foundations, if the frost is below it, to heave, to lift up, and that's bad. If it freezes here, it's not really going to push it side to side because it's going to freeze and kind of squeeze that concrete together. Concrete is great under compression, no problem. So this is what would happen with the frost heave. If this is the frost line, the maximum frost depth, this footing is great. If the soil freezes above this, no problem. The walls aren't going to be damaged. But here, it's going to freeze, it's going to cause soils to expand, it's going to heave this up, and then crack, and then the walls fall down. So here's a frost depth contour map. You're going to use this for the assignment. These little contours represent the depths of frost, how deep they might go. So you can see up here, in South Dakota, it's about a 40-inch frost depth. There's a number here that says 39. These are supposed to be, I think, sort of averages. Minnesota number seems a little odd to me that it's 38 because it's up into that 45 line there. However, they just try to give you some average numbers here, but the contour lines show roughly where that frost depth actually goes. So you can see it's quite a bit deeper here. When we lived up in Alaska, the frost depth would be down around 6 or 7 feet. So we dug our foundations to about, I think it was about 8 or 9 feet to put our footings in. Flood elevation, if you are in an area where floodwaters are, then you want to avoid that because it can cause damage to the structure and to the contents of your home. So the height of the floors is dictated by building codes and should be above flood levels based on historical flood information. So there are flood maps that say, okay, this is an area that frequently floods, and so you are located in a flood plain, and so they no longer allow people to build in flood plains. And every now and then you'll get like a 500-year flood like what happened here a few years back, and then there's really not a whole lot that can be done against that. Your house just gets flooded. So drainage, ground should be sloped away from the building to provide drainage. A drainage pipe is along the edge of the foundations, and if we went to a job site, we would be able to see that drainage pipe. And the ground floor should be located 6 to 8 inches above grade. For example, here we have 8 inches above grade here. And it's sloping down and away. And here's this little drain tile pipe. You can see a footing and then your foundation wall. Your footing is really, really thick. Foundation wall goes on top of that. And it slopes grade away from building at 1/2 inch per foot. And we are going to sort of simulate that in our design.